So we've just run the pairs command in the ggplot2 package to get a scatter plot matrix of our data frame of the different runs estimators we've been talking about. And here's the output. The output doesn't look readable at all. We can hit the zoom key when we're looking at the plots, and we get a better resolution picture of the data, all the scatter plots we want to look at. But we can also use the export button, and we'll do that for the video here so we can get a nicer resolution image of the scatter plot matrix. So let's call this the runs estimators scatter plot matrix, and save it as a PDF, and we'll view the plot after saving, and it should pop up here. Let's reduce the size one step, move it to the middle here. Good. So let's look at what the scatter plot matrix is. Let's talk through this. The scatter plot matrix takes every variable in the data frame, and there is 4 in our data frame. Team runs, runs created basic, extrapolated runs reduced, and Palmer and Thorne's linear weights. Now, what each of these plots is are given by the placement of the 4 different variables. So let's take this plot right here. This plot right here, and it's true for all the other plots, this plot right here has runs on the x-axis, and we know that because all these plots here have runs on the x-axis. All the plots here have runs created basic on the x-axis. So wherever the placement of the variable lies is where you see the x-axis. So if we take this plot again here, this is runs because it lines up with runs, and this side is runs created basic because it lines up with this. This plot here is runs created basic, and on the x-axis is extrapolated runs reduced. So you can see on any given plot what's on the x-axis. Here's linear weights, and on the y-axis is extrapolated runs reduced. Now the plots that we really want to look at are these 3 right here. These 3 right here at the top. What we have here is the scatter plot of runs created basic formula, extrapolated runs reduced, and linear weights against team runs on the y-axis. Now let's look at all the different plots here in the scatter plot matrix and try to get a sense of what's going on in the relationships between each of these variables. So look at the various plots closely, observe, try to find some kind of relationship. Obviously there's some relationship between these variables. There's a pretty strong correlation going on in these different plots here. But your job looking at the scatter plot matrix is to try to find different plots that might show something interesting. So the value of the scatter plot matrix is looking at any relationships you can see and observe between the variables of interest. So this process of reducing your data frame to the variables of interest and looking at a scatter plot matrix is useful for the data scientist. So look, observe, and try to see something there that might generate questions for you. Now another thing to note here is the mirroring going on between these different plots. Let's look at these 2 here. Let's look at this plot and this plot. In this case we have on the x-axis linear weights, and then here extrapolated runs reduced, and it's flipped on this plot here. This is extrapolated runs reduced versus linear weights on the y-axis. And you can see that by looking at the cloud of data points that show up. They're flipped around this diagonal on the middle of the plot. Just as you flip the axes between the two different variables, so you flip the data as well. So there's mirrors here between all these different plots, and you can see that if you look carefully. So look carefully to convince yourself that these are mirrors of one another, just flipping the data around the diagonal of the plot itself.